All right, so let's first start with some notes. This might help some of you who are having trouble with Pythagorean Theorem. So first of all, the Pythagorean Theorem only works in right triangles, okay? Nothing else, only right triangles, so that's super important, okay? It cannot work in any triangle, it has to be a right triangle. So the way you know it's a right triangle is if it has a 90-degree angle. Only one, because it would be impossible for it to have more than one. The Pythagorean Theorem is a relationship between the side lengths of that right triangle, of a right triangle. The formula, super important. You're going to need this formula. Okay, you need to know what it represents and how to use it. So you may want to write down that formula. That's the Pythagorean Theorem. You're going to need that all the way through Algebra 1. So in this formula, the A and B values represent the legs of a right triangle. If you look at this diagram, okay, you see A and B are labeled. Those are the legs. These are the legs because they form the right angle. Okay, you see how it makes a capital L? They form the right angle. So the two legs form the right angle. And what's cool about the legs is that A can be here and B can be there. They do not matter. The order for A and B do not matter because we're going to add them, okay? That's a commutative property of addition. We can just add them. A plus B is the same thing as B plus A. In this case, we're going to square them and then add them. So C is the hypotenuse, okay? The hypotenuse is the part of the right triangle that is directly across from the right angle. What they like to do is they will change this picture and they will edit it in multiple ways and they will draw the right angle at different parts. Let's say that my right angle is here. These would be my legs, okay, this side length, and this would be my hypotenuse. A lot of people like to think is it the diagonal part, but I don't like that because if they turn it, if they change the angle and rotate it, then A and B are up here and C is the hypotenuse. Just pretend that's straight. So that hypotenuse is always across from the right angle. That's your safe bet there. And the legs are the sides that form the right angle. So to actually work problems here, let's say I have a right triangle with a right angle. They'll give you measurements. Like they may say this is 5 meters. This one's going to be 6 meters. And they may say, what is the diagonal distance? Or what's the missing length? So first you have to decide, okay, well I know I'm going to need my formula, a squared plus b squared equals c squared. You decide what a and b are. So remember, a and b are your legs. They form the right angle. So in this case, a and b would be 5 meters and 6 meters. Remember, it doesn't matter, okay? It does not matter the order. So I'm going to call a 5 meters and I'm going to call b 6 meters, and I could switch those. So in this case, this would be 5 squared plus 6 squared equals c squared. Now we just evaluate these. Remember, exponents, when I'm squaring this, this is 5 times 5, not 5 times 2, 5 times 5, which gives me 25. This is 6 times 6, which gives me 36. That equals c squared. Order of operations tells me I need to add these, so that gives me 61 equals c squared. Now I'm not finished because I'm squaring this and I need the inverse. Well, the inverse operation for squaring something is to square root both sides. So now I need to find the square root of 61. Well, I know it's not a perfect square because there's nothing I could think of that times itself would equal 61. So that's when you go to your calculator. I sent you a link to Desmos. Okay, this is it, Desmos, and I do the square root right here of 61, and it already shows you my answer, but if you want to hit enter, you can. So if you notice, this is an irrational number. Remember, it's not a perfect square. This is an irrational number. So let's say I'm going to round to the nearest hundredth, so that would be 7.81. So when I go back here, I know that c squared equals 7.81 meters. And really this is an estimation or approximation. So I can use the squiggly equal sign, which means about 7.81 meters. Now I've found this missing length. So that's probably, I would call those level 1 questions. Actually, I would call this level 2. Level 1 are a little easier. These are typically perfect squares. In the measurements, we call these Pythagorean triples. So let's say I had 12 meters, 16 meters, and they want me to find the missing part. So remember, A and B, that doesn't matter. This time I'll do A here and B there just to prove it. So A squared plus b squared equals c squared. My a value this time is 16. I have to square that. My b value is 12. I have to square that. I don't know my c value. So I will square these and add them. Well, 16 squared if I need to go to Desmos. This is how you do 16 squared. You put 16, it is squared, 256. So I go back here, so that's 256. Plus 12 squared, you should know, 144. That gives me c squared. Use your calculator, go ahead and add these up. I know what this is. This is 400. That equals c squared. The inverse operation of squaring something is to square root. So I take the square root of 400, which is 20. That's exact. This is a perfect square, rational number here. I don't have to use positive and negative because this is distant, so it would not be negative. So my answer would be 20 meters, would be the length of this hypotenuse. So you may say, okay, well, why do I need to know this in real life? What does this have to do with me? They love real world problems here. 90% of them have to do with a ladder leaning up against a wall. This is going to be my ladder. Okay, just go with me. Here's my wall. And it's based on where they're placing this ladder on the wall. So here's my right angle. I want to know if somebody's in a window. Maybe it's, you know, the house is on fire. I don't know. Let's say it is 22 meters, this tall building. 22 meters up is where the window is, okay? I want to know if I can save them with a 25-meter long ladder. I want to know how far I will have to place it from the building, okay? Because, you know, the closer I place it, it will be steeper, but the further it will be less steep. So I can move this ladder, and they want to know how close do I need to actually move this ladder. So we would do the Pythagorean theorem here. The formula is a squared plus b squared equals c squared. So my a and b values, remember, those are my legs. So if you remember the other one, they form the right angle. Remember, they make that L. So one of them is 22 meters, but I do not know the other one. Okay, so one is 22 meters, and I do not know my missing leg. I do, this time, know my hypotenuse. Okay, it is 25. If you look, here's my hypotenuse. It's across from the right angle, so it is 25. I still need to square my 22 because that's part of the formula. So now I will multiply 22 times 22. I will square 22. If you need to, go back to Desmos. Remember, clear it. Remember, you can do 22 squared. Okay, nope, something's going on. 22 squared. That gives me 484. So 484 plus b squared equals 25. You should know that one, 625. Now to solve this, I have to subtract just like I would an equation. So I'm trying to isolate my variable. I'm trying to get b and b squared by itself. So I'll subtract 484 from both sides. And I will be left b squared equals, go ahead and go back to your calculator again. I'm going to cheat and use my calculator on my phone just to make sure so y'all don't get an X. 625 minus 484 is 141. Remember, I have to do the inverse operation. So I take the square root of both sides. So the square root of 141, I know this is not a perfect square. So I'm going to go ahead and use my little approximation there. So the square root of 141, I'm using my phone again. If you turn it sideways, you can do a square root. I get about 11.87 meters. So in order to rescue this person, they need to put the ladder, the base of the ladder, about 11.87 meters away from the wall to save them. So that's one case of real life. Another one, you know, when you buy a big screen TV, they actually measure it diagonally. Like if they say it's a 50-inch TV, that's measured across diagonally. So based on what size you're putting it in, like in your house, let's say I have 30 inches here and I want to know how long this TV is actually going to be in length, I could still use the Pythagorean theorem. It would be 30 squared plus x squared or b squared equals 50 squared. And I can figure out where this TV would fit in my house. So there are lots of examples in the real world. We'll get to more of that next week. But hopefully this video helps you a little bit. If you still have questions after this, please send me an email and I will help you out. Now I gotta figure out how to stop this video though.